so far, what you've done is just atoms. Atoms and only atoms, because that's what in the periodic table, and you learned about the structure of the atoms. Now we're going into a combination, okay, of atoms. So there are different things involved here. So we call them compounds, okay, when you have two atoms combined. And you remember my little dilemma before with elements and compounds, as in whether oxygen as in O2 is an element or a compound. I think of it as a compound, okay, because it's a combination of two atoms. But chemists can also consider that as an element because that is how it exists, okay, on Earth. So it's a little bit of a gray area. For me, it's not, okay. For me, O2 is a compound, okay. And I think if you keep it that way, then you will not have any confusion. So compounds are different kinds, okay, and so basically there are two different kinds. You go down. Covalent and ionic. Okay, so there are two kinds of compounds that we talk about. Covalent compounds are also called molecules. So they exist as molecules, as we say. So for example, any example that I give you in there, okay, for covalent compounds like water, that can be considered a molecule, all right? Ionic compounds are a little bit different. They're also called formula units, okay? So they're not called molecules. So two different kinds, covalent and ionic. You remember that the periodic table is classified into at least two parts, which is the metals and the non-metals. Okay, so we're talking about the left-hand side of the periodic table and the right-hand side. The metalloids are a little bit different, as you know. Okay, metalloids can go either way, as in being metals or non-metals. Covalent compounds are formed from only non-metals, which means that you will find them only on the right-hand side of the periodic table. Okay, you don't find them on the left-hand side of the periodic table. Ionic compounds, on the other hand, they are formed from metals and non-metals. That's the key thing. But I want to give you a little bit of an introduction for bonding because it makes the understanding a lot better. Okay, so there are two kinds of bonding. And I'll start with the ionic first because this is the easier one. And covalent. And ionic is from metals plus non-metals. Covalent is only non-metals. That's one thing to remember. Two, ionic is formed from transfer of electrons, whereas covalent is sharing, yes, of electrons. So when we say that we have transfer of electrons, it means that one type of an atom is going to give electrons, the other one is going to take it as a transaction that happened and we're done with it, okay? Whereas in the covalent bonding where you have sharing going on, that means both of the atoms are either equally or unequally sharing electrons, okay? So then number three, in ionic compound, you have ions, and in this one there are no ions. Although that's a lie, there are ions, but it's a little bit different. Okay, we will talk about that when we get there. So it's not completely true. You can still have ions and you can still have covalent bonding, but it's just slightly different. We don't call it the traditional ionic bonding because there is no give and take of electrons and there's no metals in there. Okay, so it's just a little bit different. So in any case, ionic bonding, metal, non-metal, transfer of electrons, and have ions, which means that when you talk about ionic bonding, you're talking about the bonding between left-hand side of the periodic table and right-hand side, okay? Please get comfortable with the periodic table so that when you're looking for calcium, you're not looking on the right-hand side of the periodic table. You're looking at the left-hand side, okay? Otherwise, it's going to take you forever to find any element, okay, in there. So get comfortable. That's why I said, you know, keep the periodic table everywhere they want. Okay, so once you have these two classifications, then we can go ahead and talk a little bit about some kind of nomenclature, okay, because one of the most important things that we have to do now is talk about naming compounds. And as I go through with all the rules with you, you will see that all these compounds, they either fall in the ionic structure or they form in a covalent, okay, structure. So either way, one of them will fall into. So the first one I will take is ionic. Oh, in ionic compounds, first of all, you have metals and you have non-metals and you have transfer of electrons. You have ions. So let's talk about all of these things over here. Okay? So there are two kinds of ions possible. You have a cation and you have an anion. So there are two kinds of ions. Cation is positive, anion is negative. Cation is formed from gain or loss, anyone? Loss of electrons. Okay, formed from loss of electrons, and these are formed from gain of electrons. You don't really have to think too much or think that you have to memorize too much, because obviously if you gain electrons, you gain more negative charge, correct? And so therefore, your atom, when it becomes an ion, it will be negative because you've gained more negative charge, okay? If you give away electrons, okay, then your balance is towards more of the protons than of the electrons, okay? Because remember, protons and electrons are equal. So if you give away electrons, then you have more of the protons left in there, okay? That's how it is. So you form a cation and the anion. All right, so you have positive, loss of electrons, that. And the third important thing about cation is that metals form cations. Whereas non-metals form anions. Here is one thing that you should be aware of from now until the end. There are very few things in life that are for sure, okay, that is absolute. So even in chemistry, as we go on, most of the times when we say all of these things, this is all true, okay? 99.9% of the time this is all true, but 0.1% of the time it may not be true, okay? So for example, I can say that metals will always form cations from the loss of electrons, but I cannot always say that metals will always have loss of electrons, because sometimes, in some cases, metals will also gain electrons, okay, in some cases. So again, when things get more complicated, when you start having more information, then you learn more about it. These are general rules. There will be only very few things that are for sure, and I will tell you that, okay? Otherwise, please be ready that you can have exceptions everywhere, okay, in all cases. So that's something you should be aware of. Okay, so cation, anion. So let's talk a little bit about cations and anions before we really get into forming a compound. Let's take group number one. And group number one is called alkali metals, okay? Please just know all of these things and say them also as you go along. Alkali metals, and do remember that hydrogen is not your typical element, okay? So it's in group one because it can lose an electron, but it's not in group one because it's an alkali metal. Hydrogen is not an alkali metal by any means, okay? And so that's something that you should be aware of, that hydrogen is really a weird one, so I will not even talk about hydrogen. We'll go to lithium, okay, straight away. So alkali metals like lithium, sodium, potassium, and so on, all of these, they will all lose one electron. So with lithium, where you have an atomic number of 3, it means that you have how many protons? 3 protons. How many electrons?
3.
3 electrons. And I'm saying that you lose 1 electron, correct? All right, so when it loses 1 electron, how many electrons does it have now? 2 electrons, and it still has 3 protons. So the residual charge is +1. Okay? So you calculate the charges this way, and by the way, I'm doing it for you now. You will never have to do it again. Okay? Just so that you understand how we get these charges. And the same thing happens for sodium. Sodium has 11 protons, 11 electrons. Gives 1 away. It still has 11 protons, but now 10 electrons, so 1 excess of positive charge. Okay? So that's what happens for group 1. It loses only 1 electron. It doesn't lose more than that. When we get to bonding, we're going to learn why it does that. Okay? So the beautiful periodic table that I gave you today, if you want to use that, you're most welcome to start writing on it. So you can write +1 on that group. Okay? Because group 1 will always be +1. That's for alkali metals. The alkaline earth metals, group number 2, will always give 2 electrons away, so this will always be +2. Okay? And in case you're wondering, where are the electrons going? Where are they going? Eventually they will go to a non-metal, right? Because non-metals will take electrons. So it's not just the sodium just gives its electrons away. Away doesn't mean away. Okay? Somebody has to take it. So a non-metal will take it, which is what we learned in compounds. Okay? So we will do that too. So group 1, +1. Group 2, +2. Group 3 is +3. And by the way, this is 100% true. Okay, this is something that will never, ever, ever, ever change. Okay, group 1 will always be +1. Group 2 will always be +2, which means group 2 will never be +1. Group 1 will never be +2. You see what I mean? Okay, that's always for certain. That's something 100% true.
When you say group 3, does that include the metalloids?
The metalloids, no, does not. Yeah. So when we talk about all of these ions, then we're talking about metals only. Okay. So aluminum actually is a weird one because aluminum behaves more like a metal than a metalloid. Okay. And otherwise it can also have a little bit of non-metallic character. All right. But otherwise, if you have to think of aluminum, think of it as 3+. Okay. Always. All right. So that's this. And then group number 4 is a really weird one, okay, because group number 4 falls right in the middle, okay, of the whole periodic table. So group number 4 also has non-metals in it, okay, because carbon is falling in the non-metal category, and then you have silicon and germanium, which are falling in the metalloid category, and then right here with the tin and lead, it's completely metallic, okay, and so you have this non-metals, metalloids, and metals in here. Group 4 is going to be plus or minus 4. Okay, so you can write that down. -4 is going to be for carbon, +4 is going to be for lead and tin. Okay, but you need to write one more thing down here is for, okay, so group 2 is +2, 3, +3. Group 4 is ±4. But the lead and tin that we have, lead and tin, they can be +2 or +4. So which means they can be both. Okay, you can have +2 as +4, which means that lead and tin are capable of giving either 2 electrons or 4 electrons. So depending on what they are combining with, you can have both of those kind of compounds. Okay, which leads to a little complications in naming, but we'll deal with that. Okay, because you can have various combinations. All right. Then getting on to group number 5. Group number 5, now we're getting into non-metals. Okay, and non-metals like to take electrons, right? Because they form anions. So when they're taking electrons, you get a negative charge. So group number 5 is going to be -3. Group number 6, -2. Group number 7, -1. And the noble gases are too noble to bond with anything. They don't hang out with anyone. Good? All right. Let me give you an example for group number 5. Okay, so this is 2, 3, 4, and then group 5, which is nitrogen and phosphorus then. Okay, so nitrogen, as I said, this is -3. So group number 5, number 7. So nitrogen has atomic number 7, which means it has 7 protons and 7 electrons. Okay, and what we are trying to say is that it gains 3 electrons. It likes to have 3 more electrons, which means that you're adding 3 electrons, which means it has become a total of -10, and here you have 7. Okay, or let me change that, excuse me. 7 protons and then 10 electrons. Okay, and then when you do the addition of that, you still end up with -3, okay, of a total charge. Good? Okay. That's how you get the charges. That's how you form ions, okay, by give and take of electrons. Always remember, left-hand side positive, right-hand side negative. Okay, so those numbers that you have, those are going to be good for now and forever. Okay, so please remember them. Very simply said, group number 1, 2, 3 are very, very easy to remember because it's just positive 1, 2, 3. Okay, so easy to remember. For the anions, you can go from right to left if you want to. Okay, because the halogens are -1, then oxygen is -2, and the nitrogen group is -3. So from right to left, that's going to be -1, 2, 3. Okay, and the middle one is 4 plus or minus 4. Good so far? Okay. What are these called? Sorry. Over here, what are these called? The transition metals. Okay, the transition metals are really weird. Okay, the transition metals, because they are metals, they will form only cations or anions. They're transition metals, cations. Okay, so they're transition metals. Metals always form cations, so which means that these will all form cations. All right, that's not a doubt. The problem with transition metals is, and you will learn this later on when we get to bonding, is that transition metals can give various number of electrons. They can either give 1 or 2 or 5 or 7. So you don't know how many electrons they're giving. Okay? I will never have you figure that out. Okay? If I have you figure it out, you will have some clues, okay, as to how many electrons a transition metal has given. But otherwise, keep in mind that the transition metals are still metals and they will still give electrons. Okay, so they will always form cations. Okay, questions? Good? Let's get into nomenclature now. And nomenclature means naming. Very fundamental stuff. This is something you learn now and you use forever. And some of the naming is very instinctive, that you just know that this is what the name is going to be. Some of it you have to have certain rules for it, okay? And again, if you're learning this for the first time, please make sure you learn it correctly, okay, with the right rules. So we're going to do ionic first, okay? That's where I started with over here. So told you about the charges. Now we're going to do 2 kinds of nomenclature within the ionic, okay? We're going to do main group, okay, which is group 1 through 8. And then we will do transition. So the main group elements, the nomenclature is different. For transition metals, the nomenclature is slightly different. Okay, not that different, all right, but a little bit different. Okay, so there are different rules for it. Covalent bonding have a different rule. So when we get to covalent compounds, then we'll deal with that. Okay. And please keep the rules separate because you can't mix and match. Okay, we are very, very specific in how to name all these compounds. So for main group elements, we're talking about 1, 2, and then 3, which is the boron group. Okay, and then right-hand side. So ionic compounds, again, form from cations and anions. So we're going to take the most simple compound possible, which is NaCl. Okay, which is also something that you are aware of very much. And this is where your symbols will come into play a lot. Okay, so please learn your symbols as you're going along, because if you don't know your symbols, your naming is going to be wrong. There are 2 components for any naming. So you have the left-hand side and the right-hand side. You just name from the left and go to the right. Pretty much that's it. Okay, so what's on the left is sodium. Okay, so you say sodium, but then this is chlorine, but the name changes slightly. Okay, so it becomes chloride. You can leave a space over here. You can also use small letters, it doesn't matter to me. Okay, that's all fine. Your symbols have to be in the correct letter form, but your naming can be anything, but do leave a space here, okay? So it's not just all one word. So sodium chloride. Sodium does not change its name, but the anion will change its name, okay? That's always going to happen, that the anion will change the name, or the second element is going to change the name, okay? Correct. All right, one of the things you should be aware of for any compound that's formed, unless we get into ions, which we will, is that all compounds are neutral, electrically neutral, all right, which means there is no charge left over, okay? So let's look at that for 1 second. Here we have NaCl, which means that you have Na, which has a charge of 1 positive because it is in group number 1, okay? So it has a 1 positive, and then chlorine, which is in group number 7, is supposed to have a charge of -1. Okay, so +1, -1, you have a total charge of 0. Okay, so if you want, you can do a little addition over here and say, okay, well, this is 0. Okay, that's it. Okay. One thing you will see over here, that we've started using the third corner. Did you see that? Did you notice that? Okay, all right. So these two are for the mass number and atomic number. This one on the top right hand is for the charge, and this down here is going to be for the number of atoms, okay, you have in a compound. So for example, let's go on to something like this. A compound between calcium and chlorine. The name would be calcium chloride. The charges over here, okay, that we have, calcium is 2+, and chlorine is -1, right? It is still -1. You just happen to have 2 of this. So therefore, the total charge becomes -2, and therefore, the total here is still 0. Okay, because you have 2 of the chlorines. It doesn't mean you have Cl2 minus. This is not what happened, so I will never ever write this, okay, because that's not what happened. Good? The language of chemistry is really important, so please, don't mess up anything. So for example, I would also never write something like this. That's not possible also, okay? Because this shows me that I have 2 chlorines that are combined together and they both have a negative charge, but that doesn't exist, okay? So, and how do you know it doesn't exist? You will learn, okay? As we go through this chapter, you will see which compounds can exist, which one cannot, and this one does not exist for now. Take my word for it, okay? All right, so with the calcium chloride over here, you can see that nowhere does it tell you that you have 2 chlorines, does it? No, you don't know that, okay? Because the name doesn't say di or 2 chlorines anywhere, okay? And that is because we are in the main group right now, okay? When we're in the main group, there is only one kind of a combination possible. Since calcium is 2+, and calcium is only 2+, nothing else. Because it's only 2+, it can combine only with 2 chlorines. Okay, it cannot combine with any other number of chlorines. So you will never have any other number of chlorines. So you never need to write how many chlorines there are because there's only one formula possible. Okay, one combination possible.
Is that why hydrogen, like hydrogen dioxide, because hydrogen isn't in the main group technically?
Hydrogen is a little different. Okay. And also with, and hydrogen is also a little different, and sometimes when you get to non-metals, then things are a little bit different. They can combine differently, okay? When we get there, you will see that. But hydrogen, that's why I took it out, because hydrogen is not an alkali metal, okay? Hydrogen technically is a non-metal, which is why it's placed on the right-hand side, but it's also not a halogen. So it doesn't belong in group number 7 either, okay? So it's just weird, all right? But even non-metals will have various combinations, okay? So it's a little bit of a problem when we get there. Not so much, actually for naming it's very easy. Okay. All right, so calcium chloride, okay, over here. Now, what if we have it the other way around? So for example, if I say, write me the formula for magnesium oxide. So if you have to write me the formula for this, which you will have to, okay, eventually, is how do you write this? Well, first of all, you get the right symbols, okay? So magnesium is Mg and oxygen is O. Okay, that's the first thing you do. The second thing you have to do is you have to look at the periodic table and figure out the charges for it. Okay, magnesium is
2+.
Oxygen is -2. Okay, and then you see how can I combine these two so that I don't have any charge left over. Okay, because remember a compound has to be electrically neutral. All right, so combine them in such a way that they turn out to have equal charges. So here you have +2 and here you have -2. The formula will be simply MgO, okay? All right, so let's try with aluminum chloride. Work with me here, okay? Please, class participation. Aluminum is +3 and chlorine is -1. So to make it electrically neutral, how many chlorines or aluminum do you need? 3 chlorines, okay? And you can look at the charges over here and you can decide that. The other way to do it, which is really very easy to do, is do a crisscross method like this. Okay, so you're cross multiplying, okay, with each other. So which means that aluminum, you will have 1, and then chlorine, you will have, oops, that's odd. You will have 3. You just don't put the charges down there, you just put the numbers there. Okay, that's all it is. And of course, if you have 1, you don't put the 1 there, so this becomes aluminum chloride. Okay, so I want to go through one thing here with you, okay, and that is the anion. So the ide that I'm mentioning to you over here, the chloride, the oxide, okay, so I want to go through this with you on the periodic table. So if you have your periodic tables, you can write it on it, okay, or if you don't want to write it, that's fine. But you have to go through this with me at least once, okay, so that I know that I've covered it and you know it too. Okay, so we're going to start from group number 7, which is the halogen group. Okay, and what we're going to do is we're going to change the ending so you can see how it ends. Okay, so fluorine becomes fluoride, chloride. Go ahead, say with me if you're comfortable. Okay, bromide, iodide. Okay, that's what it becomes. So you take out the ene and it becomes iodide. Okay, in there. Group number 6, which is the oxygen. There are very few, okay, to do. There are not that many to do. Oxygen becomes oxide, sulfide, selenide. Okay, selenium becomes selenide. Okay, the nitrogen. Nitrogen becomes nitride, phosphide, okay, and then arsenide. You will probably not encounter that many arsenic compounds, okay, but otherwise, you know, you would probably just, you know, manipulate that little bit. Carbon is called carbide, not carbonide, carbide. Okay, so no N there, carbide. And you will not have anything for boron. You will have for hydrogen. Hydrogen is called hydride. Okay, you got them all? This is it. Okay, this is it, pretty much. For all the anions, this is what you will need. All the cations that we have, all the cations will never, ever, ever, ever change their name. Although never say never, right? Never say never. Yeah, because when you get to chapter 18, suddenly things will change, all right? I don't know. But in any case, for now, things don't change, okay? So cations will always remain as whatever names you have for the metals. Magnesium, calcium, potassium, scandium, whatever it is, okay, will remain the same. It's only the non-metals that are going to change. Good? All right, that's your main group elements. Now let's go on to transition metals, okay? Transition metals rules are slightly different because, as I said, metals, the transition metals can give different number of electrons. Okay, so the easiest one to talk about here is iron oxide, and iron can be iron 2 plus or it can be iron 3 plus. There are two ions possible, which means that iron can give either 2 electrons or it can give 3 electrons. Okay, and so which means if you're trying to combine this with oxygen, which oxygen never changes, it's a main group element. Oxygen is -2, okay, always. -2 always. So form the compound for this. Go ahead, don't wait for me. You form your compound. Do you want to tell me? Huh? No, give me the formula first. We'll talk about the naming later, but give me the formula for the first one. FeO. And the formula for the second one? Fe2O3. Everybody okay with this? Yes? Okay. All right, so FeO, Fe2O3, which means that both of them are, as you would say, iron oxide. Okay, so then if I'm asking you to write the name or the formula for iron oxide, which one do you pick? Okay, because then you don't know which one to pick. Okay, yes. So when you have a charge of 2 plus for any ion, then you will go ahead and name that. And the way we write this out is iron 2 oxide, and iron 2 here. These belong together, oxide is separate. Okay, so iron 2 tells you that you have the 2 charge, okay, on there. Please remember, for iron 2 oxide, something like this, you have to have the brackets here, you have to have the Roman numeral over here. Okay, that's the rule. This is just the rule. There is no other way to do it. So this will become iron 3 oxide. Don't leave it like this. Do not leave it like this. Okay, put the brackets around the 3. Good? Yes?
What's the difference between the two?
Well, in one case iron is 2, the other case iron is 3 plus.
But they're the same thing?
They're not the same things. Okay, because they're combining in a different way.
Okay.
All right, so when you form a compound, that compound will have different properties. Okay?
And you would use those properties to identify which one it was?
Yes. You can use that, or these 2 compounds, maybe they're used for different things also. Okay? Yeah, because they have they have 2 different number of oxygens in them. Okay? So this is something that happens in transition metals all the time. So let's try something else over here. Let's try chromium 2 oxide. Go ahead and write the formula for this one. And if you're done, go on to the next one. Chromium is Cr, and oxygen is, of course, O. Cr plus 2, and oxygen is -2. So the formula is 0. That's it. Okay, that's the formula for chromium 2 oxide. There is nowhere in this formula that you have 2 anywhere. This 2 is to do with the charge, okay, not with the number of atoms or anything like that. Okay. Copper is, symbol is Cu. Cobalt is Co. Copper is Cu. Okay. Cu, and then chlorine is Cl. That's your first step. Okay. And then copper is, and the formula is. Is everybody okay with this? Yes? Okay. Fantastic. And silver oxide, the formula is quickly. Okay. I'm happy. I don't know about you guys. Okay.
So with the transition metals, the way we know how many electrons it has is by the number inside the brackets.
This is it. That's
And
the
if we
only
don't
way.
have that, we can't find out what.
That's it. You can't. Okay, so I have to tell you that. If I don't tell you, it means it's a typo. Okay, that I did not tell you that. Although I will tell you one thing. Okay, if you look back into your notes from just about 30 minutes ago or 20 minutes ago, you will remember that I said over here that tin and lead can be 2+ or 4+, right? Now tin and lead, would you classify them as transition metals? No. Don't be afraid. Just say no. No. Okay, you will not. This is the main group. Okay? They're main group, yet they can be +2 or +4, which means that when you name any compound with tin and lead, you have to use the 2 and 4. Got it? Those two are exceptions there. So you have to use that. So when I say that I have PbO, which is lead oxide, it is not just simply lead oxide anymore. Okay? It has to be lead 2 oxide. Okay, so even though we're talking about a main group element, you have to say that, okay, in there. On the other hand, there are exceptions in the transition metals, okay, and the exceptions in the transition metals are actually zinc and silver. Okay, I use silver over here because sometimes you do get the silver 1 oxide, but you may not get it because silver and zinc, these two elements, they will always remain zinc as 2+ and silver as +1. They never change. Okay? So there are exceptions in all cases. Good? Okay. All right. You know, your chapter summaries that you have, there's a big chart at the back that I gave you. Okay? So please refer to that, you know, for your nomenclature needs because it is complete. Okay? I tried to make it as complete as I could. So this table that I gave you here, this got all the ions in there. Okay, so please go through that and use that as a guideline, okay, when you're working. All right. So now I'm going to get into covalent compounds. And by the way, just a little tidbit here, do not think about memorizing how many charges any transition metal has. There's no point right now. Okay? You get that by practice. It's not something that you sit and memorize. I don't need you to do that. So which means I don't need you to know that iron can have up to 2 charges on there. Okay? 2+ and 3+. There's no need for it. Okay? So chromium can have 2+ or 3+. No need for you to know that. All you need to know is how to name things. Okay? And how to use the name. But you don't need to know how many charges it can have. Okay? There's because manganese can have up to 4 or 5 different ions in there. Okay, so don't waste your time with that. Okay, covalent compounds are sharing electrons, and these are non-metals, just to review, which we just did. And the simplest covalent compounds, okay, which you need to know, are the diatomic, gases or diatomic compounds. These are the weird ones because their name is exactly the same as the element. Okay, it doesn't change. So for example, there are only 7 of these. Okay, so write them down. Starting from oxygen, nitrogen, hydrogen. They have the same name as the compound, which is why they're considered as elements also. And then you have the 4 of the halogens. Okay, so F2, Cl2, Br2, and I2. These are the only 7 diatomics out there. When we get to the next chapter, I'm going to teach you how to figure out whether we're talking about chlorine as in Cl or we're talking about chlorine as in Cl2. Okay, that you will learn in the next chapter, all right? For now, if we say chlorine, please say Cl2. If you're using chlorine for bonding, use Cl. So these halogens, oxygen, nitrogen, and hydrogen, okay, they have the same name as the element itself. Okay. Now let's get into nomenclature. In these cases, when you have two nonmetals, you don't have a cation or an anion. Okay, as we know that. There are no ions formed in covalent compounds. So which means that when you're dealing with something like hydrogen and chlorine, hydrogen is not really a metal, okay, but it is written first, and if it is written first, you don't change the name of it, okay, you leave it as it is. So which means it becomes hydrogen chloride, okay, that's all it is. The compound that is formed between carbon and oxygen. There are two compounds possible, with one oxygen and with two oxygens. Now you're aware of both of these compounds, and you call them carbon monoxide and carbon dioxide. And I chose this because you're aware of these two compounds, okay, already. So which means that to differentiate between the two compounds, you have to use a prefix in there, okay, a mono and a di. And that is something that we use in covalent compounds all the time. Okay, we don't use the mono and the di in any of these compounds over here. Okay, for these ones we had charges, we had the Roman numerals. Okay, we don't use di-tri. But for covalent compounds, you have to use prefixes. Okay, so over here, if you want to give yourself a little hint here somewhere, so right, use prefixes. And what prefix do we write? Let me give you all of them from 1 through 10. And you can say them with me if you want to. 3, 4, 5, 6, 7, 8, 9, 10. 1 is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Usually you will not encounter anything more than 10, okay, in a combination. So those are your prefixes that you're using. The first element, if it is 1, then you don't use mono, okay, for that at all. You just leave it as it is, and that's why this was carbon monoxide, and this is carbon dioxide. So the prefix is pretty much for the second element, not the first one. This would be phosphorus trichloride. So the second element, you will change the name. The first one, leave it like that. So phosphorus, oops, wrong spelling. Trichloride. So you can see that the naming actually becomes very easy, okay, because tri itself is telling you what combination you should have, okay, in there. You don't have to think too much about the charges because there are no charges in there. Okay, so NO, NO2, N2O, N2O4, NO3. Have fun, write the names. I'll give you 1 minute. Okay, let's see if I remember the names. Nitrogen. Say that again properly. Nitrogen. Okay, all right, let's do that. Very good. All right, nitrogen monoxide and wait. I have a method for my madness, Dominic. Okay. Dioxide. And then Christian? And how many nitrogens do you have? So you're going to use the prefix? Okay. All right. Dinitrogen monoxide.
Dinitrogen.
Very good. Dinitrogen tetroxide. Very, very fine there. And then?
Nicholas, but it's nitrogen trioxide.
Very good. Go ahead, write the name for this. Diphosphorus pentaoxide. Diphosphorus pentaoxide is P2O5. Dihydrogen monoxide is H2O. Yeah, next time you go to a restaurant, that's what you should ask for. Why do we have some dihydrogen monoxide? Okay. Good? All right. That's the most fundamental nomenclature system with the main group elements, the transition metals, and then where you have covalent compounds. The last part about nomenclature is polyatomic ions. And polyatomic ions stand for the fact that you have polyatoms. Polyatoms means more than one atom in there. When I said diatomic before, diatomic stands for two atoms. Polyatomic stands for more than one atom. Okay, and there, whatever combination there is. And then it's an ion, which means that you have an ion in there. Okay, so when I was telling you before about nonmetals and ions, this is really what I was talking about. Okay, over here. So we have many polyatomic ions. But there are a few that I'm going to pull out for you. Those are the ones you need to know absolutely. The rest you can use your cheat sheet, okay, if you want. But the ones that I write on the board, you must know those. Okay, there is no other way for this. The only positive ion, polyatomic ion that exists is this one, NH4 plus. Okay, and please, I hope you don't mind, and in fact, I encourage you to do so if you want to. Is when you have one positive or one negative, circle it. Okay, so that you know for sure that this is a charge, because you will see that you have pluses and minuses for other things also, but when you circle your charge, then you know exactly what it is. Okay, you can also write +1. So for example, you can write +1, but that 1 is redundant. Okay, so I usually just write it like this, and my Cl- is like this. Okay, for 2- oxygen, 2- you can write like this, or you can also write like this. Okay, that's fine. Either way is fine. Just don't write it like this. That's not good. Okay, so put things in their specific positions, but otherwise this is fine. You don't need to circle it. If you feel like circling it, you can go ahead and do that. If it's your habit, that's okay. I have no problems with that. Okay, if you don't want to circle your sodium ion also, I'm okay with that, but I circle mine. Okay, that's all I just wanted to say. Okay. This one is the ammonium ion. Ammonium ion, the way it's written right now, it does not give you a clue that you have nitrogen in it or hydrogen in it, does it? Does the name say anywhere that you have hydrogen or nitrogen? Does it tell you what charge it is? No. Okay? Ammonium ion just says ammonium ion. That's it. You have no idea whether it's positive or negative, but once you get to know it, then you know it's a positive. Okay? You get to know it. Please get to know it. Okay? So the ions that you need to know, this one, okay, for sure. And then let me get my cheat sheet so I make sure that I get all of the main ones for you. They're all in here also, in your chapter summary. Okay, so you need to know carbonate, which is CO3, 2-. you will need to know cyanide. Let me write cyanide separately. Cyanide and hydroxide, okay, because these three over here, ammonium ion, cyanide, and hydroxide, they're slightly different because they're not the same as the others. I'll show you what that means. Let me just write the ones that you need to know, then we'll talk about that. Okay, and then for carbonate, you will have hydrogen carbonate, then you will have sulfite, SO3 2-, hydrogen sulfite, sulfate, hydrogen sulfate, oh, minus here also. These are all ions, so you have to have a charge for everything. And then phosphate is PO4 3-, hydrogen phosphate, PO4 2-, and dihydrogen phosphate 1-. And then you will also have the nitrite, O2-, nitrate, NO3-. Then you will need to know acetate, which is C2H2O2-. Yeah, that's what it is. Okay, all right. Some of the other ones that are given in this list, this is your list in your cheat sheet. You can just check mark them if you want to, if you're going through all of that. Okay, this is given to you in alphabetical way. I've just given to you in a little bit different way. So if you want, I can just quickly go ahead and write the names for you because I want to show you some trends over here. Carbonate, hydrogen carbonate, sulfite, hydrogen sulfite, sulfate, hydrogen sulfate, phosphate, hydrogen phosphate, dihydrogen phosphate, nitrite, nitrate, acetate. And these two, cyanide and hydroxide. What I would like you to note from all of this is, except for the three that I wrote on the top, which are a little bit different, ammonium ion is the only positive one here that you see. The other ones that are given in your books or in the cheat sheet, you don't have to remember those. There is one hydronium ion also in there. I don't consider that as a polyatomic ion because we know from nonmetals that we learned how to end everything in "ide", oxide, hydride, things like that. Okay, those two are the only ones that are ending in "ide". All of the other ones over here that you can see, those are all ending in like "ite" or "ate". The other common thing amongst all of them is that they all have what element in them? Oxygen. Okay? All of these have oxygen in them. All right? So that's another thing that's very common. The oxygens that you have in there are anywhere from 2 to 4. Okay, number of oxygens. So this is something that you really have to remember. There is no getting out of it. There is absolutely no getting out of it. So you have to sit down and memorize these ones. Then the other thing you will see, and I wrote them in a very particular format, okay, over here, is carbonate is this, but as soon as you add one hydrogen to it, then you also remove one charge. okay? And then this name becomes hydrogen carbonate. So it's still a carbonate, but because you've added a hydrogen, it becomes hydrogen carbonate, okay? You will see that here in the phosphate also, in the hydrogen sulfate also, all right? So you see some trends, and then you memorize it that way, okay? The other thing you will notice is that for carbonate, this is of carbon, so there is carbon in the name, okay? So at least carbonate should give you an idea that you have carbon in there. Sulfate should give you an idea that there is sulfur in there, okay? Nitrate should tell you have nitrogen in there, okay? Those kind of things. So whatever hints you need to give for yourself, give yourself those hints, but please memorize these, okay? The way we use polyatomic ions in nomenclature is just like any other anion, okay, which means any other non-metal. So for example, NaNO3. Sodium is sodium, just the way it is. And then you look at this and you realize that you cannot call it nitrogen trioxide, so you have to call it nitrate, okay? So far you have not learned how to name 3 elements, so please do not try to do so. Okay, if you see 3 elements in any compound, it means there is a polyatomic ion, okay, in there. Don't try to be creative, okay? Just learn your polyatomic ions and name it that way. All right.